Alright, here we are. Hello, hello, hello. Alright. Hello. This thing going here today. Hi, everybody. How's everybody doing today? Hope you're doing okay. Ooh. I'm good, I'm good. Did you get, Emily, did you get your problem fixed? I hope you got my email. You got your problem fixed and everything. Hopefully that went okay. Okay, that's fine. Uh, I guess just as a friendly reminder, remember that the test is due tonight at 11:59. So, um, test is due tonight at 11:59. Remember that you'll have to scan in or take a picture of your work and then send it as a document underneath assignments in D2L. Okay. All right. So I see a few people here. That's good. All right. So all right. Give a little bit, a couple minutes afterwards. All right. So let's go ahead and get going here today. Okay. Okay. Let's get started with today. Welcome back to Tuesday. Hopefully you have a nice weekend. All right. So today we're going to continue on here within chapter 2. Again, just as a reminder, again, the homework for chapter 1 is due today, and the test here for chapter 1 will be due also today at the end of the day, so 11:59 at night. All right, so be sure that you have both of those finished here by then. All right. In any case, today we still have to keep moving, of course. So let's go ahead and talk about that. All right. Last time we ended off here in this second section here, talking about uh, prime numbers and factorization and things like that. Oh, third section, I should say. So today we're going to continue on, moving on the latter half of this particular section, talking about the factors of other numbers. And we did talk a little bit about prime and composite numbers. We defined them last time. Remember, we said prime numbers are essentially, let's go ahead and just restate that for the sake of restating. So again, prime numbers here, as a reminder, are basically numbers whose factors are itself and 1. Okay, so those are prime numbers, and composite numbers are numbers whose factors include other numbers outside of itself and 1. So we looked at it, says, okay, we look at 3. 3 is a prime number. So that's a pretty fair statement to say, because only 1 and 3 can be a prime. Only 1 and 3 divide, 3. So prime example here would be 3. A composite would be like 6. Okay, 1 and 6, of course, divide 6, but so does 2 and 3. Okay, so that would be an example there in that case. Now, today, what we're going to be doing is, like I said, we're going to expand on this topic here a little bit. So let's go ahead and discuss more about prime and composite numbers. Now, we looked at last time, I said we figured out what was a prime number, what was a composite number. That was all well and good. But today we're going to go ahead and talk about a prime factorization. All right, so that's what we're going to essentially be doing here today, is taking a number and breaking it down into its most basic prime factors. And we're going to be able to rewrite it in a couple of ways. And essentially that's what the latter half of this particular section refers to. So let's take a look at that and see what we're working with. Okay, so when we talk about prime factorization, let's go and make this definition here. All right, okay. Okay, so prime factorization basically is we're basically going to break down any number into its prime factors. Now, there's one thing to actually note here in regards to this, is that, and let's go ahead and put this note down here, we can have a repeat of prime factors. So it is possible for us to say, we could have, like, say 2 2s and 1 3, or 2 5s and 1 2, or whatever. Okay, so you can have a repeat of prime factors. That's certainly possible. Now, let's talk about some of the tips here on how we can take and break things down. All right, so to get our prime factors here, we're going to, what's the trick to this here? What's the key? Key is to basically kind of use a factor tree to see what the prime factors are. Okay, so let's start off with, what is this kind of factor tree? What is this? You probably maybe have used it before in the past, but oops. All right, but let's take a gander here. Let's take a look and see what we're working with. Okay, let's do our paint tool here. All right, so the first one there on the handout is 12. What's the prime factorization of 12? So we're going to take 12, we're going to put it up here up top. Okay, and we want to break this down into 2 individual numbers. So let's think of 2 different numbers here. Okay, let's think of 2 different numbers of where we multiply it and we get 12. So let's break this down. So we cannot, the only thing we can't do is we cannot use 1 and 12. Okay, we're not allowed to use 1 and 12 because we automatically know that those work. Okay, so I need to use prime numbers or an easy number to break it down with. So pick a prime number or pick an easy number to break it down. All right, what are 2 easy numbers we can multiply together to get 12? Okay, that's right, Natalie, 3 and 4. Okay, very fair numbers, very simple, right? 3 times 4 is 12. You could even pick 2 and 6. It wouldn't matter. Either way, that would be just fine. Yeah, both are perfectly fine. Those are easy numbers. You don't have any problems with that whatsoever. Okay, so 3 and 4 is correct. So this is the first part of our factor tree. Now the thing is that, what's the big thing here? All right, so I want to show this off and then I'll come back to the example here. What we want to do here is we want to, what's the key number 2? Key number 2 is we want to break down the number. So every number on the branches of the factor tree are prime numbers. Okay, so basically what this means is you must keep going if a branch is a composite number. So you have to keep breaking it down. I guess say keep going / breaking down if a branch is a composite number. So what exactly does this mean? Okay, in a lot of words, it's feels a little confusing, but let's go back to something practical here. So if we took a look here at our factor tree, all right. So actually, I know this is a little awkward, so go ahead and make this a bit smaller. Okay. Go. All right. So we want to be able to break this down again as long as that number is a composite. All right. Make that a bit smaller. There we go. All right. So that should hopefully be a bit easier to read. Okay. So we're going to take this 4 here. This 4 is a composite number. Okay, and that's the reason why we're going to break this down into 2 more factors. And we repeat this process as many times as we can until every branch is a prime number. So how about 4? What does that break into? What 2 prime numbers does that break into? So what times what is equal to 4? All right, 2 and 2. Good. So as we see here, 2 is a prime number and 3 is a prime number. So that the ends of the factors here, these branches, are the ones, are all the YouTube videos you have online for made? Are all the YouTube videos you have online our class? Yeah, I mean, I try and post all our classes on YouTube there. Yeah, we have this class and the 11 o'clock class. So I always put replays up there. All right. Okay, so I'm going to circle all the prime numbers here. I got 2, 2, and 3. Okay, so again, as we can see here, you're trying to review last week's and it says reviewing chapter 5. Oh, okay. You know what? I might have mixed up a couple classes there. Apologies. Just follow suit with the material there from the course. If it's again here in Yvonne, then I probably mixed up 2 courses there. So that's my bad. But just follow the content there. I know that the description may not be the right one there. Yeah, my bad. Okay, so here we got our breakdown here. We have 2 times 2 times 3 would be how we could express 12 as using our factor tree. Or Another way that it may ask you for the homework or the like is how would it be another way you could express it. Again, 2 times 2 here is going to be 2 squared times 3. All right, Waffle. We're learning some pre-algebra today. We're doing some factor trees and reduction of fractions. No. So the one thing is let's put that as a note here. I mentioned this here a little earlier. So you do not break the number down to 1 and itself. So in a factor tree, you don't want to break it down. So you have 3, you know that 1 and 3 go into it, but the only way you're going to break down a number is into its composite numbers that make that number. So you're not going to have like 1 and 3. You're just going to leave it as 3 because 3 is a prime number there. So even if I started at 12 there, Hannah, I'm not going to use 1 and 12 because then I just get back to where I started, so there'd be no point. So that's why, again, we want to make sure that we break it down into 2 composite numbers, so that way we can continue to break it down one piece at a time. So you'll never have, like, at the end 1 and something. We already know by default that that's going to automatically work. Yeah, absolutely, we can do another example. Why are there 4 2's? These 2 I've circled because that's how you break down 4 is 2 times 2. Okay, so we circle all the prime factors at the end. So that's going to be 2 times 2 times 3, which is equal to 2 squared times 3. So just another way of writing that factorization there. Things. Wow, thank you for hosting the stream there, Waffle. Appreciate that, buddy. All right, let's go ahead and try another example. All right, so I'm gonna pick another example here. So let's try 60. All right, so let's try another number here. We'll try 60. So 60, a bigger number here. Okay. Now, let's take it this one step at a time. Okay. So let's pick 2 easy numbers that we can break down 60. Again, they could be any 2 numbers as long as it's not 1 and 60. Okay. So we're going to break this down. It can be, again, any 2 numbers here, and we'll break down each number if we need to. Okay, so you could pick an easy number. You could pick, 2 tough numbers, whatever you want. So 30. 30 times what is 60, Yvonne? So I agree 30 goes into it. 30 times 2, right. So that's the answer to the problem. Yes, that we're just breaking down the numbers. That's all we're doing, Hannah. Yeah, that's right. That essentially is the answer to the problem. Ooh, excuse me. Okay. Now, let's take a good look here. We have 30 times 2 is 60. So that works. Now 2, as we know, is going to be a prime number. So I'm going to circle that because I'm going to stop there for that branch. That branch is done. 30, on the other hand, can be broken down further into 2 other composite numbers. How can we break down 30? Let 2 numbers break down to 30. So 2 numbers are multiplied together, they equal 30 there. What do you guys think? 3 and 10. That's fair, right? So 3 and 10, definitely true. All right, so we're just going to put 3 and 10. All right. Again, you could pick any combination. You could pick 2 and 15, 3 and 10, 6 and 5. Okay, all of those. 2 and 15 is perfectly fine too. Any which combination, as long as you break it down even further. So So there's a lot going on there. Thank you for the raid. Appreciate you. All right. So as we see here, 3 here is going to be, we're going to circle that. All right. And again, we know that 3 is a prime number. Okay, so that part of the branch is done. However, we can break this 10 down even further. Again, because we know that 2 besides 1 and 10, there are 2 more numbers that equal to 10. All right, so what 2 numbers multiplied together equal 10? That's not 1 and 10, that is. Five and 2 sounds fair. Okay. And if we know something here, we know that 2 is already a prime number by default. We know that from circling the one before. And this 5 is also a prime number here, just as well. So let's take stock in what we have. I'm going to take all the circled numbers, put them together. So we're going to have 2, I'll put this in numerical order, 2 times 2 times 3 times 5. So that is the breakdown here of 60. Or, again, another way to write this is 2 times 2 is 2 squared times 3 times 5. And that is the prime factorization of 60. Are there any questions about that? Okay. Hopefully that isn't too bad. Hopefully that's a little bit easier. So, all right. Let's go to where are you? There you go. Okay. Okay. So we did some of that. That's fine. All right. Shouldn't be too much of a problem. So we did a couple of those, so that's okay. All right. So we're gonna pick. We're gonna do one more example here. So just letting you know, we're doing one more example here with a bigger number. I just want to see if there's any other good examples that I like. No. Okay. That's the last one I want to do for this section here. So let's go ahead and do that right now. Okay. Let's do one more example here. This time we'll choose a larger number here. We're not going to, this section here doesn't go too big in terms of the numbers, but again, it's important to note when you do have bigger numbers how to kind of attack those. So let's go ahead and met it out. Yeah. All right. Let's do it. All right. All right. So let's pick 225. So let's pick 225 here as our number. Okay. Now, 225 is a pretty large number. It looks intimidating, all right, because of how big it is. All right, but like I said before, let's pick easy numbers here that we can break it down with. So we want to just break it down with some easy numbers. Let's go ahead and do that. Okay. So again, we want to pick 2 numbers that are not 1 and 225. Okay, that we can break it down with. What sounds like 2 numbers that we can break it down with to get 225? Hmm. Here's a hint, everybody. Here's a way that I actually think through this problem when I see 225, specifically for anything ending in 25. How many quarters in $2.25? 15 and 15 is correct. That part is true. So if you're not sure, I always think of it that way. So 15 and 15 is correct. I can break it down that way. Another way to break it down is you could say, well, how many quarters are in $2.25? Well, 25 cents being quarters, there are 9 quarters in $2.25 or 2.25. So that's how I know it's like 25 and 9 or 15 and 15. Or if you have, if you know what 5 is, then that's fine too. So there's a lot of flexibility here, by the way. So it's not just like you have to do it with 2 specific numbers. Hey, no problem. Feel free to stick around. Hopefully you learn something. Okay, so let's break down 15 and 15. As you could probably guess, 15 and 15 break down to the same 2 numbers. So what does 15 break down to? Five and 3. Exactly. Nice. So 5 times 3 is 15. And we'll put that twice since we have 2 15s. Again, with 25, you would have 5 and 5. And 9, we do have 3 and 3. So this is what would happen. You get the same numbers here regardless. But just showing off here that you get the same, again, same answer no matter which way you go. So we circle all our prime numbers here, 3 and 5 here, broke it down. All right, I'll put this in numeric order. 3 times 3 times 5 times 5. All right, so here we get 3 squared. Again, that's 3 times 3 times 5 squared, which is 5 times 5. Yeah, spot on, Yvonne. Nice. All right, and that's our final answer for that problem. All right, great. Any questions about that? Does it matter where the numbers go on each side? No, not at all. Remember, if I say 3 times 5 is 15, 5 times 3 is 15. It doesn't matter which way you do that. Multiplication is commutative, so you can flip it around the way you want to. That's kind of nice about that. So you don't have to like worry about it. Be like, okay, I can write it however I want. Like, okay, cool. Any other questions? Nope. Nope. Okay. All right. All right. So that is pretty much the end of section 2.3, talking about those common factors there. Are we going to solve today? Yeah, we're going to solve stuff today. I hope so. I promise you. That's way to solve for factors of particular numbers, but we're going to use them for a particular something here in this very next section. So we talked about fractions last time, but one of the things that we'll need to do in relation to what we just did here in this previous section is exactly what you see up here on the screen, which is writing fractions in lowest terms. Okay, and we're going to talk about how to do that here as best as possible. So how to tell whether a fraction is written in lowest terms and write a fraction in lowest terms using common factors or prime factors, and we're going to determine whether or not they are equivalent. From the previous example there, yeah, this is all we have to do. Yeah, I was just rewriting it with this equal sign. This is 3 squared times 5 squared, or 3 times 3, 5 times 5. Yeah, that's all you have to do. Yeah, there's no more to it other than that. That I can promise you. No problem. I'm here to help. All right. So we're writing fractions in lowest terms. Okay. Now, what does the writing fractions of lowest terms mean? Okay, let's talk about what that means, because it's not exactly kind of what you're thinking here. Basically, if you remember here in a fraction, we have a numerator and denominator. Okay, we got the top and the bottom there. Okay, so essentially with the numerator and the denominator, all right, so lowest term specifically means, let's go ahead and type that in without looking terrible. Um, so lowest terms basically means that the numerator and denominator do not have any common factors with each other. And we'll expand upon this, of course, using actual numbers, but the basic idea is that the numerator and denominator do not have any common factors with each other. Now, I want to point out one important thing here. It can have a composite number. So this would be an example here, really quick, of a fraction in lowest terms. So let me go ahead and show this off here. So this would be like if I had 11 over 24. Now, it's true that 24 is a composite number. Okay, it's true you could take 24 and 4 divides 24 and 6 divides 24. All right, 8 divides 24, 3 divides 24. All that is all well and good, but none of those numbers divide 11 evenly. So if they both don't have any common factors with each other, then this is as far as we can go into reducing a fraction down. So again, the key words here are with each other. Okay, that's kind of like the big deal here. It has to work on the numerator. It has to work on the numerator as much as it works on the denominator. So one of the things that I guess we'll stress on here in this particular case, what we're going to do here specifically is when we talk about um, reducing down fractions and whatnot, we want to be able to kind of focus on one important aspect. All right, and so what's the key here for this whole section? There is a big key here for this section, and that is basically how you can basically do all of algebra. If you're talking algebra and you always get confused, the one thing that you always have to understand about algebra, it works in one very simple way, and that is the word specifically here, balance. Everything in algebra is always a balancing act. All right, and I seriously do mean everything. So um, we want to be able to balance things out. We'll see in this section here exactly how we can balance things out. But balance here is the most important thing when it comes to algebra. And any of the techniques that we're going to be doing pretty much will require us to go ahead and do that. All right. It's again, it's something that I stress on because it makes things significantly easier when you put your mindset into balancing things out. So the question is, what exactly are we balancing? How does that work? Okay, let's take a look at several examples. We're going to look at a lot of examples in this section here. We're going to go through and see what we're working with. All right. Okay, so the first one I want to do here, let's go ahead and pick one here from the handout, as there was one in the handout. Okay, so the first one I'm going to pick here is this 18 over 24. Now they give you the answer here, and that's all well and good. But I'm going to show you exactly how you can break down this 18 over 24 to this 3 over 4. Okay, that's how we're going to kind of show off here just for this first example to kind of ease into the process. All right, so let's do it. All right, so what we want to do is we want to take this, we want to break it down into its most basic form, into its lowest terms. Now, as I mentioned here, the key thing to do here is balance. And what we want to do is we want to find, oh, I guess it's down there. All right. Yeah. So we want to find the common factor that we can divide by on both the numerator and denominator to reduce the fraction. I'll put a note to this. Note, you may need to do this multiple times. So it's not just one and done. You may need to do this multiple times if there's still a common factor in between. We'll take a look at this example where certainly that can be the case. So I'm going to showcase this one off here, and I'll show you exactly how this works. So if I look at 18 and 24, and let's say, you know what, I don't know what the common factor is, but I want to keep it as simple as possible. Okay, let's say I would choose the smallest number possible. Well, one thing I do know is that 18 is an even number, and 24 is also an even number. So I'm going to divide 18 by 2, but I need to balance things out. I need to divide both the numerator and denominator by the same exact number. Again, it's always a balance. Everything is a balancing game. So I'm just going to divide straight across here. And I say, okay, well, 18 divided by 2 is 9. And 24 divided by 2 is 12. So, okay, that's fine. We did that. Awesome. But now we have to ask the question, is there another common factor between 9 and 12? And if you look at it and you say, all right, the answer is yes. There is indeed a common factor between 9 and 12. In this case, that happens to be 3. So we're going to do 9 divided by 3 and 12 divided by 3. Remember, we'll divide by the same number. And then you just do that straight across. We say 3 and 4. So we get 3/4. And then at the end here, you could ask, oh, is there anything in common between 3 and 4? And the answer is no. So this would be your answer of your fraction here in lowest terms, just like so. And that would be how you arrive at your final answer. Now, you could easily say here as well, you could divide each one by 6, to get 3 and 4. But if you feel like you want to do it one step at a time, you can go ahead and do it that way, and that'll be just as perfectly acceptable here. Okay. So there's several ways you can kind of attack this problem here. Either you could do it all at once if you can, or again do it in steps, and then just take it, shave off a little by little. Again, in any case, you'll get down to the very lowest terms here at the end of the day. Okay, let's try another. Okay, let's try another here. I've shown off this example, but now let's have you guys guide me through a couple of these problems. All right. So let's try one of the same numbers here, but just something nice, not too bad here. Okay. So let's go with 21 over 24. All right. Now, is there a common factor between 21 and 24? Is there a number that divides both 21 and 24? No? Think about that again, Jonathan. Yeah, we want a number that divides 21 and 24 evenly. 3. Yes. 3 divides 21 and 3 divides 24. Yeah, so you got to be careful here. You may have several factors, right? Again, if it helps, use the times tables, to kind of hopefully break it down into two numbers that you can see. So we're going to divide by 3 here. Okay, 21 divided by 3. What do we get here? 7. Okay, agreed. And we have 24 divided by 3. Eight. Good. So we get 7/8, which is correct, okay? And 7 and 8 don't have anything in common, so this is where we stop. Okay. Let's go ahead and try another. Okay. All right. Let's see here. All right, that one's pretty good. Yeah, we'll try a couple of these on the thing. That's page 87. So looks like 30 and 50. So let's go with that. All right. Okay. So let's look at 30 and 50 here. So first things first, we want to find a common factor between 30 and 50. Like I said, lots of possibilities. So, but what's a good common factor to go with here? 10, right? Yeah. So we could take 10, right? 30 divided by 10 is nice and clean, right? Absolutely. And same with 50. 10 is nice and clean with 50. Perfect. All right. Let's break this down then. All right, so we have 30 divided by 10 and 50 divided by 10. So what's our fraction here after dividing by 10 on the numerator and denominator? 3/5. Nice. Awesome. And this is where we stop because, again, 3 and 5 have nothing in common outside of its, 1. So there we go. All right, so 3/5 is correct. All right, let's do another one. So let's try this one here, 60 and 72. Okay. 60 and 72. All right, bigger numbers here, but again, you could either take it slow by dividing it by, some number, or you can take it fast, dividing it by a bigger number. Again, it has to be in common, though, between both 60 and 72. So whichever way we want to go. Okay. Uh, what should we divide by here? 12? Okay, that's fair. 12 is definitely true. Like I said, you could pick 2, you could pick 6, you could pick 3. There's a lot of possibilities here. So again, do understand if you picked one of those numbers, those would be just fine too. 12 is the one that I see there. So from Ola, so we'll go ahead and pick 12. That's perfectly fine. Again, you'll just have to continue to break it down if you chose like 2 or 6 or 3. Okay. What do we get here? 60 divided by 12. What's that? 5/6. Good. Okay, now I'll show off the alternative version of this. And the reason why I'll show off for the alternative version of this is, let's say you had a little bit of a tough time to finding 12. I mean, maybe that's not so easy, okay? So maybe I would pick, say, all right, both of these numbers are even, so I could pick, say, 2. All right, as you could do 60 divided by 2, which is 30. And here I get 36. And then you could divide by, here you could divide by 3 or divide by 6. Let's say you had to divide by, let's go with another 2 because they're both even. You can keep going if you like. So this would be 15 over 18. And then you could divide each one by 3. And you'd still, again, end up at your final answer here of 5 over 6. So if it takes you multiple steps to get down to 5 over 6 as opposed to one step, you can see that you can go ahead and do that as well. All right, any questions about those examples? Oops, sorry. Bring that back up. Any questions at all about those examples? Again, remember to type no in the chat if you want me to move on, or if you do have a question, just go ahead and type it out. No? Okay. One more example, okay? No problem. Let me see if we have another one here. Ah, that's a good one. I like that one. All right, let's do this one here. That's actually a really good one. So 28 over 42. Let's do that. Okay, let's go with 28 over 42. All right. What can we divide here with 28 and 42? There's several numbers here. Yeah, there's a couple numbers. So, what's a good one to kind of start with? Let's start with a basic number here. So, it's a good basic number to start with. It's a good common factor between 28 and 42. What do you think? What can we divide by here? So we got to divide by the same number here, regardless. All right, let's go with 2. Right? They're both even numbers. That sounds fine to me. All right? Absolutely true. So we get 28 divided by 2. 7 also works as well, yes. Yes, Maricela, 7 also works as well. They're both very valid. Now, if you do 28 divided by 2, that'll be 14. And if you do 42 divided by 2, you try that out, you will get 21. Then you look for a number that has a common factor between 14 and 21, which, again, as is pointed out here, would be 7. Okay, 7 goes into 14. and 7 goes into 21. All right, so we get 14 divided by 7, which is 2, and 21 divided by 7, which is 3. So our answer here would be 2/3. So you can see here, if it takes you a little time to find that common factor, that's fine. That's fine. You know, that's not a big deal. All right. It may take you a little time, cool. All right. But you can see you break it down with 2, simple number to start with, right? You got the 14 here, got the 21 here, and then see if you can find a common factor, and then maybe you get two numbers that don't have any common factors, and then you're good to go. Okay. Questions about that? Appreciate that, Peanut. I hope you're learning something off of it. I try to be poggers every day. All right. So there's a few more examples there that you can try there, but let's go ahead and take a look here at a couple more examples. This time, we want to determine whether these fractions are equivalent, yes or no. So we take a look here. Let's take a look at a couple of these, and we're going to determine whether they are equivalent or not. So after we reduce them down, yes, that's correct, Alyssa. Yes, you are correct. You could have divided by 14 because 14 goes into 28 and 42. That's correct. Yes. So you could have combined those. But if you don't see the 14 right away, then you could use 2 and 7. So that's why you could break it down just like I have up here. Or again, at the end of the day, you'll see that 14 would work if you combine those two steps together. But I know for some people that's not so easy to see necessarily because 14 is a larger number to deal with. But yes, you're correct, Alyssa. Absolutely. 100%. So if you could take one step, then go ahead and try and take one step. But it's not always easy to do that, only because the numbers could be larger. All right. Let's try in this first one here. Let's do 16 over 48. All right. And we're going to see if that's the same as 24 over 72. Now to do this one here, we're going to go ahead and reduce each fraction down to its lowest terms. And we're just going to see what we're working with. I don't know if it is, and I don't know if it isn't, but let's find out, right? That won't hurt a fly. All right. So how about 16 over 48? What can we divide by on the numerator and denominator to reduce it down? What could we do? I need to pick a number. I can divide here, and I can divide here. Got to be the same one, though. 4? Absolutely. Let's go with 4. 4 works. So if we take 16 divided by 4, that's going to be 4 straight up. And if you do 48 divided by 4, that's going to be 12. Okay, just like so. Can we divide anything on the numerator denominator now? Is it possible? Do we have a common factor here? Two? Okay, we could pick 2. Totally agree. So 4 divided by 2, we do that out as 2. 12 divided by 2 is 6. Do we have any more common factors there, Hannah? Can we divide out anything else? No? 2 and 6? Look carefully. They're both even numbers, right? So if they're both even numbers, then you could divide out one more number here. So you can notice here we can divide out by 2 one more time, because again 2 divides 2 and 2 divides 6. So we're going to get 1 over 3 here in this case, for the first fraction anyway. Are there questions about that before we move on to the second one? No, that's okay. That's why we cover this, so that way, you know, we get used to this stuff. It's the whole point. All right. How about 24 and 72? What can we divide the numerator and denominator by? What can we reduce by there? 24 and 72 we can divide by lots of numbers, I know, but go with 4. All right, seems fair. 4 definitely works. It's at 24. Yep, 24 also works. We'll go with 4 here, just to showcase this off here. So we get 6 on the top here, all right, and we get 18 on the bottom. If you do 72 divided by 4, we'll get 18. And to Ola's point here, since we already divided out by 4, and Ola put 24, notice that 6 and 18 here, we're going to divide by 6 on the numerator denominator, straight up. So here we get 1, and we get 3. So we get 1/3 in both cases, so this checks out. They're indeed equal to each other. All right. So we want to say, hey, are they equal to each other? Definitely so. They both equal 1/3, and you're done. All right, any questions about that? Okay. Okay, let's do the next one if there are no questions. All right, so I'm going to pick this next one here. So 20 over 4 and 110 over 22. Okay. So let's look at 20 over 4. So what can we divide by here at 20 over 4? What's in common that we could divide by on this? All right, 4 sounds like a bueno idea. I agree. 4 definitely divides 20 and 4 itself. So you do 20 divided by 4, which is 5. 4 divided by 4, which is 1. 2 also works, absolutely. So again, you could pick 2. So let me go ahead and put that down here. So you could pick 2 here. And if you did that, you would have 10 over 2. And then what you would do is you'd pick another 2 here, since 2 divides 10, and you'll end up with the same guy here. So it just takes you an extra step, but that's perfectly fine as well to pick 2. You just have to take that extra step by dividing by 2 a second time. So either way, we end up with the same result of 5 over 1, which is what we're after there, in that case for the lowest terms. How about this next one? How about this next one here? What could we divide by here? What could we divide by here? 110 and 22. What's our common factor there? 22. Okay, that's definitely fair. 22 actually is correct. Now you could pick 2 and 11. Both would be just fine. But we have 22 divided by 22 is 1. What's 110 divided by 22? So 110 divided by 22. All right, the answer is indeed 5. That is true. So we do have 5 over 1 and 5 over 1. This checks out. That means that they're equal to each other. Now to show this off here, if you use, say, 2 to start with, for example, because 110 and 22 may not be so easy, what you'd find out is 110 over divided by 2 is 55, and here you would get 11 as your denominator. Then you could divide by 11 on the numerator and denominator, and so here you get 5 over 1. So that's another way to kind of approach that in 2 steps if you're not sure that 22 would work right away. So just want to point that out, be like, oh yeah, magic, it happened. Okay, questions about reducing fractions? Oh, sorry. Any questions at all about that? Okay. All good? All good in the neighborhood. All right, very good. Okay, let's go ahead and move on here to the next section. We're obviously we have like 10 minutes, but we'll do a little bit of the next section here because it has relevancy to what we just talked about into putting things down into lowest terms. So we're going to do a little bit of multiplication of fractions, and we'll see how it goes. So that is the next section here. So let's go ahead and put that down. Okay. Now multiplication of fractions honestly is not too bad. Let's talk about the general rule here. So what's the rule here for multiplication of fractions? All right, this one here is actually relatively straightforward, but the process about how we'll go about doing this will be a little different than maybe what the rule says. So in any case, let's say we have a over b times, again, c over d. All right, so for multiplication of fractions, all you have to do is what we did here in the section before. When we divided the numerator and denominator by that particular number, we divided straight across. So since we divided straight across, we're going to do the same thing with the multiplication there in this case. However, division of fractions is a little different, but in any case, we'll get to that. But we have a times c. Actually, I'll put the times symbol in between there. A times c over b times d. Okay, so this is our basic rule here for multiplication of fractions. Okay, fairly straightforward in terms of the rule. You just go straight across and that's it. Not bad. Okay, now having said that, well, how do we multiply fractions here together? Okay, so how do we multiply fractions straight together here? Let's take a look at a couple of these examples here and we'll see exactly how this goes. Okay, so the first one here that we're going to do, again, let's look at 5/8 over 5/8 times 3/4. Okay, so if we did this one out, we just multiply straight across. We could have 5 times 3 over 8 times 4. And so here we get 5 times 3 is 15, 8 times 4 is 32. And after this point, we can determine if we can reduce this fraction down. Hey, it's all good, buddy. So we can take a look and see if we can reduce this fraction down. In this case, we cannot reduce this fraction down because there are no common factors between 15 and 32. Okay, so this is where the end of the problem would come, would be just that. Now let's say, for example, though, you have no idea if it reduces down after the fact or before the fact or all that stuff. All right, let's look at a practical problem here and let's see how it works. Okay, we're going to ignore some of those. So, all right, so let's look at letter B. I want to look at that one. That's actually a pretty important problem there. So we're going to look at that one specifically. Hey, Silly. Is this a legit class? Pepe laugh. Yes. Yes, it is. All right. So let's do 3/5 over 3/5 times 1/3. Now, to be perfectly clear about this, how do we go ahead and determine what the answer to this is? Now, we could technically multiply straight across, and we could technically get an answer, and then we could reduce after that. But here's the key. The key is actually doing something slightly a bit different. It makes the problem significantly easier. All right. So the key here is basically to reduce before you multiply. Okay, so we actually want to reduce before we multiply, so we don't have to deal with the reduction at the end. We actually reduce before that fact. So the question is, well, how does that work in a problem like this? Okay, so in this case here, all we want to do is look for a common factor on the numerator and a common factor on the denominator. If we put this together, technically we would have 3 times 1 over 5 times 3. Now we can see that indeed we have a common factor on the numerator and denominator. That would be 3. So we have 3 on the numerator and 3 in the denominator. So 3 on top, 3 on the bottom. So we can divide this by 3, and we can divide this by 3. And so 3 divided by 3, that becomes 1. And this 3 divided by 3 also becomes 1. So notice here that I went ahead and I reduced this down prior to actually multiplying straight across. Now I can actually do the multiplication now that I actually have reduced it down. And so here I get 1 over 5. So this is essentially what we're looking for here. Can we reduce it down before we actually do the multiplication? Because then I don't have to do as much work. So if I can avoid work, then that's a really good thing for me. All right? Being as lazy as possible is the best as possible. Okay? You got to earn the grade just like anything else. All right, let's take a look at one more here. All right, last example for this class anyway. I'll be doing the same class anyway in 20 minutes. Let's see which one of them. Okay. Yeah. There we go. Let's do 3/4 times 8/15. Okay. Are there any numbers that we can reduce down? Any numbers that we can reduce down here between 3/4 and 8/15? What do we got here, folks? We got 3 times 8 and 4 times 15. But do we have anything that we can divide out here? Anything we can kind of like, you know, pare down, if you kind of want to call it that. The 8 and the 4. Okay. So the 8 we can divide by, what can we divide the 8 and the 4 by specifically? 4. Okay, good. So for right now we have 8 divided by 4, which is 2. 4 divided by 4, which is 1. So far we have 3 times 1. 3 times 2, sorry. My bad. Should be 2 because I got that mixed up. So 3 times 2 here divided by 1 times 15. We have any other numbers that we can divide, that we can pare down or divide out? Three and 15, that's right. So if we take a look here, 3 goes into 15. We could take this divided by 3. We could take this divided by 3, since that's a common factor. 3 divided by 3 is 1. 15 divided by 3 is 5. So here we get 1 times 2 over 1 times 5. And so here we get our final answer of 2/5. That's separate than this. Oop. All right. So that's going to be our final answer for this problem. And there we go. So you can see exactly how it works with multiplication of fractions. I know these are a couple basic examples, and we'll do more for next time. But the idea is that, again, we simplify before we multiply, and it becomes significantly easier just to put two smaller numbers together. So we're trying to eliminate as much as we can before, because if you try with two big numbers, it's really difficult. So, and I don't do really difficult. I do really lazy. Really lazy is the laziest way is the best way. You know how it goes. So, yeah. All right. Are there any questions about any of the topics here today? Any questions at all? No? Okay. No? All right. Okay. So, all right. Good stuff. Okay. All right. So, that'll take care of it for today. All right. Uh, okay. I don't know what said A, but okay. Okay. Yeah, it's all good. It's all good. We all make mistakes. And no, you're not dumb. About the O. Okay. We'll just hit F in chat just for the mistake there. All right. Okay, so that'll take care of it for today. All right. Everybody, thank you very much. Thank you very much for coming out here today. I will be back in about about 10 minutes or so. So for the next class. All right, same class, but work keep working on your tests there. Make sure you finish that up by tonight. Make sure you finish up your homework by tonight, and we should be good to go. Hey, you have a good one. You have a good one, Silly. Yep, homework will be everything from chapter 1 today. Homework from today, specifically, will be 2, 3, 2, 4, and 2.5. So, yeah, so Hannah, just if you did finish any homework from chapter 1, then the 3 sections that I listed here for chapter 2 are the ones that you should continue moving forward with, because we did like 2, 1, 2, 2 last time. So, and you don't have everything for 2.5 yet, because we just got started with that. But if you want to get started with that, you can. Okay. All right. Great job, everybody. All right. We will see you all later. Have yourself a very, very wonderful day. All right, we will see you on Thursday. For those of you in 11 o'clock class, I will be back in 10 minutes. Okay, take care, everybody, and we will see you later. All right, bye.